Hello, my name is Jocelyn. This short video will be in response to a subject studies query addressing a common mathematical misconception of many secondary school students. Okay, the question we will be answering today says, you have been teaching decimals to the class and asking them to create a sequence of 5 terms starting at 0.4 and going up in steps to 0.2. A large proportion of the pupils in the class have given the answer, and the answer is as follows: 0.4, 0.6, 0.8, 0.10, and 0.12. Okay, so for this query, we have been given two parts. Part 1 states, explain why the pupils have made a mistake and identify the misconception. Part 2 states, explain how you would address the misconception and that we may want to consider some supporting features to answer. I have pre-drawn a number line to help us visualize what is going on when we add 0.2 in the sequence from 0 to the whole number digit 2. We can see after the number 0.8 on the number line, when we add 0.2, we get the sum of the whole number digits 1. Firstly, the mathematics topic materials covered is the module numbers, with emphasis made on place value. Place value deals with the positioning of number digits and the decimal point, particularly when used in operations such as addition, which is what we're using now, whilst representing these singular quantities. Other topics from the module numbers that the question relates to is sequencing and background knowledge requirements for fractions, decimals, and percentage conversions. Disclaimer, such may be required for proportion comparison checks. As an example, is a 0.8 smaller or larger than any other number in the progressive sequence, and why? This would be used to, as an example, again, maintain order. We can find supporting math content documents online under the heading Key Stage 3 and/or 4 and 5 Mathematics Specifications. These outline the curriculum coverage on the school's chosen examination boards. We also have examiner's notes as well, or examiner's reports. From the examiner's notes and/or reports, we can confirm findings of common student answers with reasonings behind such answers given. The examiner's notes and/or reports can be found accompanied with exam paper answers at the bottom of complete exam paper sets online or attached separately on examination board websites. Addressing Part 2, Clearing Misconceptions. Some very useful modes to administer correct and incorrect methods have been to use the readily accessible resources available for explaining misconceptions. These can be found on the BBC Bitesize web page. The help of past papers and mark schemes and even watching YouTube explanations along with software packages like MathsWatch can contribute towards student engagement levels. Using visuals such as the timeline drawn previously with arrows to display the leaps created from adding 0.2 to the previous digits, I believe could also have a positive impact for learner concept cementing. Embarking upon collaborative group work to discuss and problem solve misconceptions via peer-to-peer support and activity scaffolding with theory-backed research-informed practices can also be a great structured way to develop student independent thinking and collective team working.